All right, so let's talk about cones today. Let's get on to our daily excitement. All right, so be a visitor, not a resident of a place like this. And one of the differences between that is how well you set up traffic control. Traffic still is the number one way to die at work. And so it's a big deal for us because many of us working at cities and sewer districts and water districts, we work in the roads every single day. And when we're working in the roads, we're obviously at risk of some idiot with a phone. So let's try to be safer. So when it comes to traffic control, what does Cal OSHA say? Well, here's the actual rules, and let's read a few of them and summarize them. Well, 1598A, a system of traffic controls in conformance with the California Manual Unit of Traffic Control Devices for Streets and Highways shall be required to abate the hazard. So in a nutshell, what does that mean? Follow the MUTCD to control the hazard. It means you have to use traffic control when you are working in or around traffic. We have to use those procedures. You need to follow the provisions of the California Vehicle Code, and those say you have to use proper traffic control devices, meaning real full-size cones, actual signs. You can't just use made-up stuff. If you're directing traffic, you can't just use your hands. You need to have the paddle and everything else. All right, next one. Employees on foot exposed to the hazards of vehicular traffic shall wear warning garments, the ones that meet the ANSI specifications for high visibility safety apparel. In a nutshell, wear your high-vis PPE when you're working in or around traffic, which does mean if you're working on the sidewalk by traffic, you should be wearing the vest. And during hours of darkness, retroreflective material shall be visible for 1,000 feet. Remember, there are some extra high visibility PPE requirements when you work at night, particularly on faster roads. You might have to wear the reflective pants or a class 2 or even a class 3 garment, as opposed to during the day where just the t-shirt with the reflective sleeves is fine. The yellow t-shirt. An employer shall select the proper type and class of high visibility apparel. In a nutshell, the employer, your company you work for, your agency, the city of Johnville, they must figure out what PPE you need, so working at night versus working at day, and they need to provide it to you. All right, so let's move on and let's talk about these, just the item, the second one, the traffic control devices. So these come out of our friend, the California Manual on Uniform Traffic Control Devices. And the current version, it's cutting edge here, it's only 9 years old, but the 2014 edition, revision 7, it's from March. And that's the one we want. March this year is when they revised it. So they use the same one and they just evolve it slowly. And then when the feds issue a new one, they will adopt it and edit it. Caltrans is in charge of all this. All right. So here's some amazing facts about the manual. It has all the details on roads. It has everything, how wide the stripes need to be, all sorts of stuff. We only need to look at, well, it's long too. The table of contents page is 23 pages long. The whole thing is 1,400 pages long. So you can think of it as light reading. But for temporary traffic control, the type of stuff that we do is all contained in part 6. So only one section of the 1,400 pages. However, it's still long. It's, a couple hundred pages long. So 1,018 to 1,259. It includes what to wear, the different high visibility clothing requirements based on road speed and conditions. And here's the really cool part. It includes drawings and sketches. And this is one of the sketches. So they have pages and pages of these. If you need to figure out how to lay out your traffic control, you can find the sketch that looks like the road you're working on. Here, we're going to take one lane of a 2-way lane road. It tells us our signage requirements, and it tells us, distances and everything else. It's really detailed. But at, even the 250 pages of the part 6, it's a big document to carry around. Instead, what I suggest doing is getting the watch book. It's the only one I know that's of really good quality, but there may be others. And it's just done by B&I Books, which is another company, and they put it together and they update it. The current version is 2019, 14th edition. And it is filled with those drawing examples that they've resketched up. And it's nice. It's a pocket-sized book. It's only $19 at B&I Books. Don't think you want to order on Amazon because for some reason it's always like twice the price on Amazon. And as of yesterday, it's $43 on Amazon, but you can get them from BNI Books, and they even have discounts if you buy a bunch of them for all your people. But they're really a good idea. This is actually, I realized that this is the old one. It has the $17.95 price. They've raised it by $1. All right, so let's move on and talk about traffic control cones. So what are cones? These are just the plastic road, rubbery road dividers we use to lay out our traffic control zones. There's two classes of these cones. We have the 18-inch cones, which we use in low-speed traffic, so residential streets and stuff. We can get away with these small cones. And then for higher speed traffic, we need the 28-inch and taller cones, and for night work. I recommend only getting the 28 and taller. Think about this. If I don't know, I coached soccer for years for my kids, but the little flat cones we put on the field for the kids to zigzag through, if you lined your traffic control with those, how effective do you think it would be? They'd run right over them, wouldn't flinch, right? You want a cone that's big enough that when they hit the cone damages their car. They want them to realize that they don't want to hit the cones, because if they can just run over them like the soccer cones, they're gonna. We're talking about drivers here, and the drivers spend half the time going, what? Okay. All right. What else we got here? Plain cones can be used during the day. At night, they need retroreflective material. Just get the ones with retroreflective material. You don't want to have more than one set of cones. I mean, if you're maybe in, your district is a golf course, and we only have the golf cart trails, which would be traffic, and you would need the vest, then you would probably you could get away with the smaller ones. Other than that, go for the big ones. So let's talk about a traffic control setup. So this is one of the pages out of our friend, the MUTCD, and it's just a simple 2-lane road, and we're actually in this one just gonna do shoulder work. So this example right here, the cones that we're talking about, they're the ones we line, and we have different parts of the cone lines, and this is what we're gonna talk about today, or at least what we're gonna focus on. So let's talk about the 3 primary cone spacing guidelines. This is kind of the big deal for the day, the deal du jour. One are the tangent cones, and these are the ones that run parallel with where you're working. So the direction the road is traveling. The parallel cones are tangent. Then you have the taper cones. These are cones that are in an angle that close a lane. These are the cones that tell the driver, hey, you want to be in lane A, but I don't want you in lane A. I want you to move over into lane B now. So we taper the cones, which forces the cars to move out of where we don't want them to be to where we want them to be. Then the third spacing issue are what we call conflict cones, or conflict tapers. And this is where if the cones weren't there, the cars would come in and hit each other. So we have these 3 different parts of a traffic control setup. Here is a traffic control setup. And this is where we're working half on the shoulder, half in a lane. So what we needed to do in this example, by the way, this is straight out of the MUTCD where I got this image. We're putting our cones to taper people halfway across, essentially centering on the center line for our eastbound traffic. And the westbound traffic, we're pushing them kind of on the shoulder on the other side to make room. So we're essentially affecting both. Now, the thing about these is it has all 3 parts of our traffic control spacing, our cone spacing. So you can see the green ones are the tangents. The purple ones or the pinkish ones, those are a taper. And then the red is a conflict. And I'll explain it more. It's a form of taper, but it's this case, a special one. And we're going to use the table from the back of the watch book. This is the table that's put together, the same as in the MUTCD, of what the cone spacing needs to be for each speed on the road. And today, most examples, I chose 30 miles an hour. And you see the right 3 columns have 30, 60, and 15. Those are our spacings in feet between the cones. And it's our maximum spacing. We can make them shorter. We cannot make them longer. Now, as far as the speed is concerned, when you're choosing which speed, don't just look at the road sign and go 25 mile an hour zone, we'll use 25. You have to use the posted speed or the observed speed, whichever is greater. We live in California. We know that the observed speed will be higher than the speed limit. It's just the way it goes. So on a residential street, you might choose 30 or even 35 miles an hour because most of the time they go faster. Remember, physics doesn't care what the speed sign says. Physics only cares about how hard it hits you when the person, misses the cones and hits you. All right. So This is the tangent section. So you can see these four areas. They are parallel with the road traffic. So what is the spacing on these? Well, let's look at the model. At 30 miles an hour, the tangent spacing is 60 feet. So when we're laying this thing out, we're going to put a cone no further apart than every 60 feet in these straight sections. We lead into, we go through, and as we exit, if we need the exit tapers, exit the work zone. So there's how we read that table for 30 for tangent. Now, if we look at our tapered spacing, I didn't mean to hit that button. I meant to hit that button. The taper is, remember, these are the sections where we tell the driver, we no longer want you in your lane. In this case, we want you on the lane line if you're heading east. So the spacing there. Now, if we look at in the same thing, remember, I keep popping into the picture. I guess I want you to see me. At 30 miles an hour, the taper spacing is 30 feet. So that means every 30 feet or closer, we need to have cones for our taper to tell the car to get out of that lane and move over. And then in conflict spacing, let me get out of the way for this one. So the conflict spacing, remember, this is a special condition. If those cones aren't there, there is the chance that cars would just simply crash into each other. And so for conflict spacing, again, 30 miles an hour, you can see that it is 15 feet. So the cones need to be closer together. And what do I mean by conflict? If you have two cars coming together without those cones, they're going to bang into each other and we're going to have an accident. So Cal OSHA, the MUTCD, says, hey, put the cones closer together. So now you know what the three cone spacing units are. The tangent, tangent, and conflict. Taper, tangent, and conflict. Tangent is green. Taper, written down there as tangent, is actually the pinkish one, and then red are the conflict. So here's an aerial view of a tangent spacing on a vehicle. And this is in my neighborhood. And that red line represents the traffic's direction, and it's also the line between the outermost cones. You can see how this was set up. So 25 mile an hour residential street. Let's look at it at the speed of 30 and do some math. So we'll do math in a minute. At 30 miles an hour, those tangent spacing cones can be up to 60 feet apart. So let's look at the picture again. 60 feet apart, that's a long way. Now, either this is the world's biggest truck, or those cones are a lot closer than 60. The thing is, 60 is a long way apart, and if you were to put them at 60 feet between cones, you're not really going to have enough cones in California in this day and age. Put them closer together. If you look at these, it's about 30 feet tip to tail on that truck. So there's what they're spacing. They're using 15 feet where they legally could get away with 60. My advice to you, more cones is better in almost every situation. One of the things I did notice about this setup is notice that the outrigger and that one cone, they have those set in much closer to the vehicle. Now, the outrigger is a problem because it's a hard object and they have the cars going right by it. So if someone clips cones, they could hit the outrigger. And if you were up in the bucket, that could end up badly. The other thing about that other cone is it's way in. So what is that telling the cars driving? Remember, cars driving are stupid, and that's important to remember. The other thing, the other factor of these cones is what are they doing here? They're trimming trees. You can tell by the chipper on the back of the truck. I did not mean to go there yet. I meant to go here. So they're trimming trees. Now, when you drag a tree brush, it's a big wide thing. So now they cannot get through their own work zone without going outside the cones. The thing about the cones is you want to stay on the safe side of the cones no matter what. You should never step outside the cones. They did not leave themselves enough room to work only inside the cones if they plan on carrying any brush around the passenger side of the truck. All right. In a nutshell. Now, we're back to here. It's time to do some math. Now, this table has a lot of information, and it keeps going down in speeds there, but I'm only showing part of it. So we're using 30 as our starting point, but what is the relationship between the miles per hour and the spacing? It's actually kind of cool because you don't even need this table to know what the cone spacing limits are. get out of the way. At 30 miles an hour, the taper spacing, this is where we're telling people to get out of my lane and get into your own lane, are 30 feet. You just take the miles an hour and you say feet, and that's your spacing. 30 miles an hour, taper spacing is 30 feet. At 30 miles an hour, the tangent spacing is 60, which just so happens to be double the amount of the taper. So the tangent, parallel with traffic, is twice the spacing allowed than in the taper. So all you have to do is double it. So if I'm a 30 mile an hour road, my tangent, parallel cones, I can just say, man, they're 60 feet. Boom. And then the conflict spacing is half of the taper. Makes sense because otherwise cars would crash into each other. So you just divide that 30 miles an hour by 2 and you get 15, call it feet, and there's your spacing. And this works at most speeds. You can see at 45 miles an hour, 45 miles an hour, we have 45 feet on the taper, we have 90 feet on the tangent, and we have 22 feet on the conflict. The thing about it, keep it in mind, is these are really big distances. Use more cones is the best way to, improve your traffic control zone. At 50, now this is where things change. 50 is the last number that stays standard. We have 50, 100, and of course 25 feet on the spacing. Now look at the full table. At 50 miles an hour, the spacing is as big as it's going to get. 50 feet on the taper, 100 feet on the tangent, 125 feet on the conflict. And at 60, 65 miles an hour, it stays the same. So that is the biggest spacing you're able to see. And again, the spacing really is huge, and a half or quarter of that spacing is actually going to produce a better work zone. Let's look at what a work zone looks like with all that math and it applied. Again, over one of the road drawings, those cones could be 60 feet apart. On the tangent, you see the ones parallel with the truck there. The taper ones are 30. We're on a 30 mile an hour road. And you see there's other things that come out of that table. There is the advance warning sign, how far back that minute work sign has to be. The shoulder taper versus taper across the road. The buffer zone is required at higher speeds, but at lower speed it's just optional. But notice it's longer based on the road slope. So there's a lot going on, but get the tapers right. Know what your limits are, and my advice, increase their density. So my final takeaway on this is order these. Get them today. You need to have them in the truck. They will keep you from, hopefully keep you from being a statistic. All right. Like I said, we're going to focus on cones today, and that's what we did.
For more top-notch safety training for public works and wastewater utilities, subscribe to Training Link. For $99 a month, your entire team can have access to live online tailgate safety training, an extensive video library, and over 100 printable topics. Go to www.dkftraininglink.com for more information and to subscribe.